Here are some examples of some atomic symbols, and we're going to figure some stuff out about each of these. Ready, set, go. Okay, what's the easiest thing to do? The easiest thing to do is the protons. Why? Because the protons are the atomic number, and the atomic number is given down here in the bottom left. So for this one, for this titanium atom, it's got 22 protons. This iodine atom's got 53 protons. This cesium atom has 55 protons, and this radon atom has 86 protons. Okay, kids usually do pretty well with that, so let's move on. Next, let's look at the neutrons. And to figure out the neutrons, you need to remember a couple things, that protons weigh 1 atomic mass unit, and the neutrons weigh 1 atomic mass unit. And if you add those together, what you get is the atomic mass. So if you want to get the neutrons by themselves, then you need to subtract the proton number. So we'll do that. We'll subtract the protons from each side. That'll cancel out. But whatever you do to one side, you got to do to the other. So the neutrons equals the mass minus the protons. So now this is not too difficult. For this titanium atom right here, the neutrons is going to be 49 minus 22. So what's that? That's 27 neutrons. And then what's going on with this iodine atom? Well, I picked a big one here, so I don't know if I can do that in my head. So here's my calculator. So 127 is the mass, that's the protons and the neutrons, minus the protons, which is 53, and I get 74. So this guy's got 74 neutrons. 130 minus 55. Well, might as well use the calculator again here. So 130, that's the mass, minus the protons, and we get 75. I feel like I should have been able to figure that out, but oh well. And then this big old radon atom right here has a mass of 222. That's a heavy fella. So we're going to have 222 minus 86, and we get 136. So it's got 100 and what was that? 36? Let's check it out again. 136 neutrons. Okay, so 136. So neutrons, also not too big of a deal. Okay, last thing on this video, I want to do the electrons. How do we figure out the electrons? Well, to figure out the electrons, what we have to do is we have to look at the electric charge of the atom. So don't think, right off the bat, don't think that this number is the electrons. Yeah, that's it. It's 2. No, that's not it. That is not the number of electrons. That plus 2 is the electric charge of the atom. And the electric charge tells us the balance between the protons and the electrons. So these two go together to help us figure out the number of electrons. Let me explain what I mean. So we know we've got 22 protons. We've already established that. We've got 22 pluses. Okay? And we've got an electric charge of plus 2. Well, you've got to remember that the electrons have a negative charge. Each one has, a -1 charge. So just for a minute, imagine this. Imagine you had 22 pluses and 22 minuses. Those two would add together to make 0. So in that case, we wouldn't have any electric charge. But right here, we've got a plus 2 charge. So that means we've got our, whoa, that's pretty sloppy. So we've got our 22 protons, and I don't know why it's doing that, but it is. And we need a number of electrons that is outweighed by the number of protons. This plus 2, here's the way that I think of it. We've got 2 more pluses than minuses. In other words, we've got 2 more protons than electrons. So if we've got, that just upsets me the way that's sloppy. Oh well, anyway. We've got 2 more pluses than minuses. So if we've got 22 pluses, we must only have 20 minuses. Because if you have 22 pluses and 20 minuses, what do these two add up to? Positive 22 and negative 20 add up to positive 2. So you have to use both of these numbers, the protons and the electric charge, to figure out the number of electrons. So let's jump over to this next one here, this iodine atom. We've got 53 pluses, or 53 protons. And how does that, look at this -1 here. What's going on there? Well, that -1 means we've got one more electron than proton, because electrons are negative and protons are positive. So if we've got 53 protons, that means we must have 54 electrons. Because think about it, if you have a positive 53 and a negative 54, and you add those up, what do you get? You get -1. Okay? So really the problem for students is that they don't like that electrons are negative. You know, if you get more electrons, then your charge actually goes down, it doesn't go up. Okay, so let's jump down here. This one, this cesium atom, there is no number here. What's going on there? If there's no number there, that means that there is no electric charge. If there's no electric charge, then that means the number of electrons equals the number of protons. So it's just 55. This atom right here is not what we call an ion. An ion is an atom that has a charge. So all three of these other guys, this titanium, iodine, and this radon, these guys are all ions. Anyway, that's a future quiz. So let's get over to this radon atom before I start talking over 7 minutes. We don't want to hear me for 7 minutes. So let's see, we've got 86 pluses, and we've got 9 more pluses than minuses. That means we must have less minuses. So if we've got less electrons, less minuses, I'm going to subtract 9 from 86. So 86 minus 10 is 76. So I'm going to say 77. Okay? Now let's think about it to see if we did it right. 86 pluses, so we got 86 pluses, and we've got 77 minuses. If you add those two together, what do you get? You get 9. So that tells us we did it right.